Hi there friends, welcome back to the channel. In the previous episode, I discussed opportunities for electrical design engineers who are working in the medium voltage space. Medium voltage space, as I mentioned, is typically defined between 1 kV to 15 kV. In today's episode, we are going to discuss opportunities for electrical design engineers who are operating in the high voltage space. Again, depending on the region, depending on the standard that applies, high voltage can be anywhere from 15 kV and above, sometimes 69 kV and above, and sometimes anything above 1 kV is considered high voltage. Again, it really depends on the standard that you're using and your geographical location. Again, it really depends on the standard that applies in your jurisdiction. A lot of equipment manufacturers typically consider voltages above 15 kV to be high voltage. Now, from the standpoint of codes and standards, if you're talking about NEC and Canadian Electrical Code, generally anything above 1 kV is considered to be high voltage. Now, things are a little bit different in the IEC non-NEC world. But for simplicity's sake, let us assume that anything above 15 kV is being treated as high voltage. And typically it is at this point that utilities get involved. Generally speaking, the primary side of your service entrance equipment, whether you are talking about residential, commercial, or industrial applications, the high voltage, the primary side of the incoming transformer, the service entrance transformer, would generally be more than 1 kV. Sometimes it's 33 kV, sometimes it's 15 kV, and so on. Sometimes even 69 kV. The world of high voltage electrical design engineering is dominated by two players. The first one are your utilities, the electrical distribution companies, who may also be responsible for transmission and generation. And for electrical design engineers, the other big employers are engineering consultants who specialize in high voltage engineering design. You also have the original equipment manufacturers, the ABBs of the world, the Siemens of the world, the Eatons of the world, the Schneider Electrics of the world, SELs, and so on. A lot of times these OEMs also have their engineering departments, and they can also provide turnkey projects to their clients when the clients are primarily using or exclusively using their equipment. Let us start with the first case, utilities. Now, electrical utilities are a big employer for electrical engineers. They hire tons and tons of electrical engineers who are interested in power systems engineering, who have academic training in power systems engineering, and who have skill set and expertise in power systems engineering. Over the last few decades, utilities have taken the approach of having a smaller in-house engineering team that overlooks the contractors, the consultants, and the designers, which basically means that if you're on the side of a utility, you're acting more as owner's engineer. I have carried out that role, and it is very interesting, but I generally advise junior engineers and even intermediate engineers to seek opportunities in hands-on design engineering. If you're working as an owner's engineer, which I did for some part of my career, as I mentioned earlier, you're typically overseeing the work of other consultants. And if you yourself have gone through similar projects in the past, you can make meaningful contributions to the project, provide helpful directions to the consultants and the contractors, and along the way, also learn different aspects of high voltage engineering project to project without actually doing the design work. But again, if you really want to bite your teeth into actual design, a better place to start is a design firm. I also mentioned original equipment manufacturers such as ABB, Schneider Electric, Eaton, General Electric, SEL, Siemens. Since they manufacture a lot of high voltage equipment, you can also get your hands dirty as an application engineer. Somebody who's actually designing the switchgear, somebody who's actually from the vendor side providing the transformer or the VFD or the generator or the entire substation. And you can get really good at it after doing a few projects, but at some point it may start appearing as cookie cutter. I started out my career in engineering consultancy. I worked on multiple different projects that helped me gain exposure in different industries, low voltage, medium voltage, and I also touched high voltage in some cases. Then I moved on to the owner's engineer role, where I had consultants and the contractors working for my employer. Acting as a lead engineer, I was providing them direction for the project, reviewing the reports, creating scope of work for them, and helping the project move forward on the electrical side of things. High voltage engineering work is predominantly in the transmission and distribution and generation space. So you need to be working directly or indirectly for your local distribution company, for the electricity transmission provider, or the generator. There's several opportunities in this space, and you can carve out an entire career in the sub-specializations, such as high voltage protection. I help students prepare for FE electrical exam and the PE power exam, which are the two exams you need to take in the US in order to become a PE. And my students work in different industries, in different geographic locations in the US, and different roles and have different responsibilities. Based on my interaction with so many different students within power systems industry, I know so many engineers who are in huge demand just because of their relay programming skills in protection and control for high voltage engineering. They can do system studies, protective device coordination, program the relays, do the commissioning, start up, install them, troubleshoot them, train the operators from one project to another project to another project. Similarly, if you want to specialize in equipment specifications, you can carve out an entire career and keep on doing that for the rest of your life as an electrical design engineer. In short, there are tons and tons of opportunities for you as an electrical design engineer. The skills that you accumulate as an electrical design engineer in power systems industry, whether that is in low voltage, medium voltage, or high voltage, takes time, and they are in huge demand, especially if you also have PE credential. Not only is this role extremely interesting, creative, and engaging, it is also very lucrative. Along the way, if you can gain some field experience, you can also turn into a commissioning manager and a specialist for starting up projects. If you're a professional working in this space, I would love to hear from you. Please share your thoughts and suggestions in the comment section of this video. And if you like this video, please give it a thumbs up and consider subscribing to the channel. I'll be back again with another episode in our series on exciting careers in power systems industry. Thank you. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE electrical and PE power students over here. And if you want to learn more about preparation of FE electrical and computer exam and the PE power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.